The journey begins where most stories end. Post-consumer plastic bottles arrive by the ton, compressed into tight bales.
Each bale is bound with steel wire that must be carefully removed to release the compressed bottles.
The bale breaker tears apart the compacted mass, loosening bottles that have been crushed together for months. Human eyes catch what machines miss. Workers manually remove caps, labels, and non-PET contaminants.
The trommel screen acts like a giant washing machine drum, loosening paper labels through friction and rotation.
An air classifier uses vertical wind to separate heavy PET from lightweight paper labels. Infrared sensors identify plastic types instantly, ejecting any non-PET contaminants with precision air jets. Powerful grinder blades chop the bottles into chips, while water injection controls dust and begins the cleaning process.
The friction washer uses hot caustic soda and mechanical agitation to dissolve glue and remove remaining labels.
In the float sink tank, density separation occurs. PET sinks while remaining caps and rings float away. A centrifuge spins the flakes at high speed, throwing off excess water like a washing machine's spin cycle. Hot air dryers remove the final moisture, preparing the flakes for melting and extrusion.
The clean flakes are pneumatically conveyed to the extruder hopper, ready to be melted down.
The hot pellets are spun dry in a centrifuge, separating them from cooling water instantly. Melt filtration removes any remaining microcontaminants through fine metal screens under extreme pressure. The molten polymer is extruded through tiny holes and sliced by underwater blades, forming uniform pellets. Now the recycled PET is melted again, this time for transformation into textile fibers. Solid-state polymerization increases the molecular weight, making the PET strong enough for carpet fibers.
The enhanced pellets are stored briefly, then conveyed to the fiber spinning hall.
The molten polymer is pushed through tiny spinneret holes, creating hair-thin filaments cooled by horizontal air quenching.
Heated Godet rollers stretch the fibers 3 times their original length, aligning polymer chains for strength. The stuffer box crimper adds zigzag waves to the straight fibers, giving the carpet its bulk and texture.
Carding opens the fiber tufts and combs them into a continuous web, aligning the fibers for strength. The cut fibers are compressed into bales for easy transport to the carpet weaving facility.
At the carpet mill, the compressed fiber bales are opened and fed into the carding machine.
The cut fibers are compressed into bales for easy transport to the carpet weaving facility.
At the carpet mill, the compressed fiber bales are opened and fed into the carding machine.
6 pairs of eyes ensure only the right bottles proceed, removing anything that doesn't belong.
Inside the rotating drum, friction and gravity do the work of 10,000 hands. High-velocity airstreams separate materials by weight with surprising precision. In milliseconds, unwanted plastics are identified and removed with targeted air bursts. Hardened steel blades spin at 1200 RPM, turning bottles into chips in milliseconds. Measured doses of caustic soda break down organic residues and label adhesives.
Density separation occurs naturally in water. PET sinks while other plastics float away.
Centrifugal force throws off 90% of the water in seconds.
Electric heating elements raise air temperature to 120 degrees Celsius for final drying.
The moment of transformation, molten strands become solid pellets.
Quality checks ensure each pellet meets exact specifications before continuing.
Nitrogen gas creates an oxygen-free environment for safe polymerization. Precision assembly of the spinneret ensures uniform filament diameter. Controlled airflow solidifies the molten filaments without creating internal stress.
The speed difference between roller sets stretches the molecules, increasing tensile strength.
Heat setting locks the drawn structure, preventing shrinkage during carpet cleaning.
Mechanical crimping gives the fiber memory for bounce and resilience. Crosslapping folds the thin web back and forth, building thick, even layers for the carpet base. Finish needling increases density and creates the final carpet surface texture. A secondary jute or polypropylene backing is bonded to the latex for dimensional stability. A layer of latex adhesive is applied to the back, locking the fibers in place and providing stability. The carpet passes through a 150-degree oven, curing the latex into a flexible, durable rubber backing.
Finish needling increases density and creates the final carpet surface texture.
A layer of latex adhesive is applied to the back, locking the fibers in place and providing stability.
A secondary jute or polypropylene backing is bonded to the latex for dimensional stability. The carpet passes through a 150-degree oven, curing the latex into a flexible, durable rubber backing. Rotating blades shear the surface to a uniform height, creating the plush texture underfoot.
Quality control inspectors check every meter for consistency, thickness, and color uniformity. The finished carpet is precisely rolled to specific lengths, ready for packaging.
Each roll is wrapped in protective film to prevent damage during shipping.
Finally, the rolls are palletized and secured for transport to homes and offices around the world. From discarded bottles to finished flooring, the transformation is complete. Mechanical crimping gives the fiber memory for bounce and resilience. Precision blades cut the continuous toe into staple lengths perfect for carding. Hydraulic pressure compresses the fluffy fiber into dense, transportable bales.
Rotating drums with wire clothing tease apart the fiber tufts into individual strands.
The carded web emerges as a thin, even veil of parallel fibers.
The crosslapper builds multiple layers, creating thickness and dimensional stability. 15,000 barbed needles punch through the layers, entangling fibers vertically. Adjustable penetration depth controls the final carpet density and hand feel.
Quality checks ensure the needled felt has uniform density before backing application.
The latex backing compound is mixed to exact viscosity for proper penetration.
The doctor blade meters exactly 2 millimeters of latex onto the carpet back. The secondary backing aligns perfectly with the coated carpet edge. 3 heat zones cure the latex progressively to prevent surface cracking. Controlled cooling prevents thermal shock and dimension changes. Spiral blades spin at high speed, clipping the pile to exact uniform height.
Backlighting reveals any hidden defects in the carpet structure.
Precision edge trimming ensures every roll has clean, square sides. Controlled tension ensures the carpet rolls are firm but not stretched.
Stretch film protects the carpet from moisture and dust during transport. Each roll is labeled with its recycled content certification and specifications.
Cross-stacking creates a stable pallet that won't shift during shipping.
Recycled PET carpet, where sustainability meets craftsmanship and waste finds new purpose under your feet.
From waste to wow, transforming spaces while protecting the planet.
50 plastic bottles become 1 square meter of beautiful, durable carpet.
Certification verifies the carpet's recycled content for environmentally conscious buyers. The journey completes as containers are sealed for international shipment. Final wrapping protects the entire pallet from weather during outdoor storage.